Welcome to the latest episode of the Aranex podcast, brought to you on Monday the 19th of June 2023. I'm Craig Eason, podcast host and maritime broadcaster. I'm also editor of the Fathom World website. Now, we all know that shipping is based on technology, heavy technology, and as an industry it is dependent on the technology companies to develop the decarbonisation solutions so that it can continue to carry customer cargoes around the world. There was probably once a time in history when ship owners had their own technology departments, but today very few have that resource. Instead, they rely on technology solution companies such as the engine makers and the clean tech firms and other companies with the resources to invest in decarbonisation research and development. Now, last week, the engine makers and other technology makers met for the biannual Congress of CeMAC. CeMAC is the International Council on Combustion Engines, so it's where the likes of MAN and Wärtsilä and WinGD, Mitsubishi, Hyundai, and lots of researchers and developers and engineers come to discuss the latest findings. This particular meeting took place in Busan, South Korea, and was the first CeMAC Congress for 3 years, having been delayed due to the pandemic. But these are 3 years where a surprising amount has happened in shipping. So for Fathom World and Aranex podcast listeners, the CeMAC Congress is an opportunity to get a sense of how engineering firms believe the transformation of these technologies is developing. The sentiment at a CeMAC Congress can give assurances, or otherwise, to ship owners and the regulators, such as those that will meet in London in a week to discuss the levels of ambition of the decarbonisation of the industry. Gavin Lipseth was in Busan for the Congress and has written a number of articles which can be found on the Fathom World website, and he's also filed this report for the Aranex podcast from the Congress floor.
How do you remove carbon emissions from an industry hooked on nearly 300 million tonnes of fossil fuel a year? One unconventional solution was spotted at the opening ceremony of CeMAC Congress. Carbon was cut from Bo Cerup-Simonson's title on his introductory slide, announcing him instead as the CEO of the Maersk Mc-Kinney Møller Centre for Zero Shipping. But it will take more than words, or in this case, their absence, to decarbonise shipping. The finale of Cerup-Simonson's keynote speech became a rallying call for the week. If you want to go fast, go alone. If you want to go far, go together. Where does that leave an industry that needs to go both far and fast? The evidence at CeMAC was that solutions are emerging and that the industry is finding a direction. However, no one should be under any illusion about how disruptive the change to zero carbon shipping will be. Here's Christoph Rofke, president of turbocharger company Accelleron's medium and low speed division, talking about the dramatic changes he anticipates for technology providers and ship operators in just the next 7 years.
We work with the hypothesis that by 2030 all new builds will be dual fuel capable. So one fuel is net zero and the backup fuel is fossil. That's just an assumption, and we took it basically, we copied from this Getting to Zero coalition. They make studies and so on, and they say if by 2030 5% of the global fleet with fuel, 5% of the fuel used is net zero, then we are basically on a good track, because it's an S-curve learning. So we are ready for an exponential uptake. And if you calculate a bit, if then any new build is dual fuel, the industry is doing then quite fine for being net zero towards 2050. And if you, with this assumption, just I would say a year, maybe 1.5 years ago, everyone would have said you are crazy. It's impossible. But if you see where the order book is now for dual fuel engines, just last year, if you just look at the contracting last year, it was almost 50%. So I think now we are from 1 year to another, from being it's likely not possible, we are even ahead of this curve. For me, it looks like it should be easy then by 2030 to have 100%. Yeah. And maybe it's 95. It doesn't matter, but it helps at least us in the thought process. So what do we need to do to support this? To catch up, and then there will be, I believe, players in the industry, the industry champions. By 2030, they already have the first or second learning curve incorporated in their portfolio. So and they will gain business. Yeah. And those who take a too conservative approach might not even have completely rolled out the initial version. So there is now a market dynamic we have not seen for long, you know, and that makes it very exciting. But it's also so that no one can lean back, because the champions from yesterday might not be then the industry champions in 2030.
With methanol orders flooding in and ammonia technology development advancing, the move to dual fuel is well underway. The scale-up of green fuel production, however, is not, with multiple experts highlighting the scale of the challenge, particularly the amount of renewable electricity that will be needed. In the absence of clarity on fuels, engine developers are having to think even beyond dual fuel capability. Here's Dominik Schneider, Vice President of R&D at two-stroke engine designer WinGD, explaining why he was to be found opening a panel on fuel cells on the last day of this engine-centric conference.
We all talk about hydrogen as the base fuel, but hydrogen has storage issues. So in merchant shipping we have to look at derivatives like methane, ammonia, methanol for green fuels. And these fuels are scarce, will become available very slow, so that means we have to do everything we can do on the propulsion plant on board the ship to make it more efficient. And here electrical devices come in, and they can really help to further squeeze down the energy consumption by better and more smart integration. The main engine size will gradually be reduced over time, so it's in future it's really the question between fuel available, energy converter available, and of how much longer is there the internal combustion engine, to what size will matter in that respect, and what is it replaced for. And if you do have the integration system that controls the energy flows for the main propulsion, you can somehow control that. And the industry reacts fast to it. First movers, they are really looking into that and look into that particularly and specific for their own applications and operation patterns. And that makes the whole thing actually very interesting. With the main engine, the two-stroke slow-speed engine, we have the biggest energy converter on board, the biggest energy consumer, chemical energy, hence the fuel. And if we can optimize the operation point of that engine with all the electrical devices in its peripheral environment to a sweet spot where is the best possible fuel consumption constantly, then we gain a lot actually, and that's what we try to show here in this presentation.
New technologies were discussed in detail across the Congress, from fuel capabilities to hybrid power to energy-saving technologies and digital optimization. But there was also a growing sense that new ways of applying technology are also needed. Faced with a zero emissions target that is barely one vessel lifespan away, conversation is turning to how existing ships, not just new ones, can be prepared for decarbonisation.
So, first challenges for retrofit. There is already, let's say, a good concept on the engine part, but when we retrofit a vessel, complete vessel. So we need to integrate fuel handling system.
Philippe Renaud, a senior R&D manager at Container Line CMA CGM and a stalwart of CMAC, explored how retrofitted carbon capture could decarbonise the company's substantial LNG fuel fleet. But he made a wider point about applying new technologies. Vessels need to be prepared for upgrades from their initial design, and all technologies should be retrofittable to encourage wide uptake of emissions-reducing solutions.
Something we say we can dream of as a ship owner would be to have ships running on conventional fuels and all the drawing ready for when we do the modifications, so that we know when we invest in the asset that okay, this is the asset we use up to next 5-10 years depending on the advance of the technology, and then okay, this is how we'll retrofit the ships. So then we can already think about the financing, we can think about many things, we can have discussion with the shipyards. It's doing a retrofit on existing ship is super challenging. It costs a lot. So most of the time the business case is not that good. If we want to have a significant penetration of this new energy, also to give perspective, to give traction to the investors when they would like to invest a massive plant for the production of these molecules, that okay, we can ramp up as quickly. So then if you place a big production site in this area, okay, then we accelerate the entry of the ships.
A big ship owner calling for greater emphasis on vessel conversions should be a wake-up call to technology developers and ship designers. Retrofitting has benefits in terms of the sustainability of shipping, lengthening the active life of vessels, reducing early scrapping, and reducing risk for ship owners. Here's Sagram Nanda, General Manager of Product Management and Engineering at Wärtsilä, explaining part of the rationale behind the company's emerging range of efficiency and fuel flexibility solutions for two-stroke engines on mid-life vessels.
A lot has happened in the last 2 years. There's a full thrust that we need to decarbonize, and we simply can't wait till the end of the decade and we say the new fuels are there and new engines are there, and then we can actually then decarbonize now. Or we have a step change. You can't do a step change. There has to be this gradual movement down, and the market has to accept that. If you have to have a new build, you cannot just build a big ship tomorrow or day after it is available, and or in the next few months. There are slots. There's a shipbuilding industry that has to build ships, and there's simply not enough capacity for them to build ships to that extent that we can decarbonize. That's point one. The second thing is that, do we need to scrap a vessel which is less than 10 years old, saying that, okay, fine, we scrap a 340,000 deadweight vessel because it has got an engine which weighs about 1,000 tons, but it cannot burn a different type of fuel. So we scrap all that steel because of that, and then we produce do a lot of mining and produce steel to build a new vessel, which also has a carbon footprint. So from a life cycle perspective, when you look at it, does it make sense? Answer is no, because we need to do something with existing vessels, and that's where the challenge comes in from a customer perspective. The customer says, it's to build or not to build. Do I build a new installation? I wait for another 3 or 4 years till I have a new vessel coming in with a particular engine type that can burn one particular fuel, whether it is methanol, ammonia, or LNG, or do I convert my existing engine and I'm ready in a few months? And I have the vessel back in service. I can meet the new requirements. I can economically, it makes more sense because I don't have a stranded asset. It's in service, and I say, okay, I deploy my asset now in a route for decarbonization, and that's where you look at that. This decade is a decade of retrofits, and that brings an altogether different challenge, because we are used to building engines that are on the shop test, goes for sea trials, and the engine is out for the rest of the life. We do some small upgrades. So now we're talking about big upgrades on the engine to make it fuel flexible.
That's a technology provider shifting the focus away from high-margin equipment for new builds, joining an engine maker talking fuel cells, and a momentarily decarbonisation hub. A disruptive CeMAC Congress for a disruptive moment in how ships are powered. But more than that, a real sense that in the technology sector at least, shipping sustainability efforts are moving from rhetoric to reality.
Journalist Gavin Lipseth in Busan, South Korea for the CeMAC Congress 2023. Now, the next Congress is going to be in 2025 in Zurich, Switzerland. And in Gavin's report, we heard that one shipowner, CMA CGM, has been assessing the potential of capturing CO2 from a ship's exhaust. Onboard carbon capture is an idea which is already a reality with some shipowners. Regular Aronnax listeners will have heard an episode earlier this year which included an interview with Netherlands-based company Value Maritime. Value Maritime has developed a technology which works a bit like a land-based carbon capture system and a bit like a shipboard sulfur dioxide scrubber, a technology which is already on board hundreds of merchant vessels. As many of you may know, the week before CeMAC I was in Oslo, Norway for Norshipping and moderating the discussions on the Blue Talk stage. These were a set of curated talks I and the Norshipping team, as well as an industry committee, had created to reflect the hot topics in the industry. Now, on one of them, there was a topic of onboard carbon capture. Value Maritime founder Martin Lodeviks was on the stage alongside Alicia Fredriksson, who's the founder and CEO of another young company, Seabound, along with Wärtsilä's Sigurd Jensen who has also appeared previously on an earlier Aronnax podcast as the company began its journey to create a modified exhaust cleaning system. Also on the stage was ship owner Solvang in the form of Tor Øyvind Ask. Now, Solvang has been keen to look at onboard carbon capture, launching a project last year with Wärtsilä, and then a week ago announcing it and Wärtsilä are part of a larger 13-company consortium, which includes other ship owners. Solvang, by the way, is a gas carrier owner shipping LPG and other hydrocarbons, and is going to put a first carbon capture unit on a vessel on a transatlantic voyage. So here's some snippets on that particular Blue Talk, starting with Alicia Fredrickson talking about the launch of Seabound and the onboard tests of her system in the coming weeks.
We reviewed all of the different types of carbon capture technologies out there to try to figure out how much could they cost, how much space would they take up, how technology ready, what was the technology readiness level, and really tried to figure out what could be most specific or most suitable for ship-specific constraints. We built this model to compare and contrast options to figure out where we wanted to make our first bet. We spoke to customers, so specifically ship owners, to try to figure out what were their key challenges and questions in relation to onboard capture. And through that, we sort of built our design criteria to figure out what we would be comparing our different technology options against. And finally, we spoke to many experts in the space to see what was the state of these technologies and could we team up with any of them. And through this, we picked a second generation of carbon capture technology. It's called calcium looping. So some of the things we found through this research process, as you might know, there's two main steps to carbon capture. So there's the capture phase, where you bind the CO2 to some sort of a binding material. And then there's the regeneration phase, where you separate the CO2 from that binding material. And so these two phases typically happen side by side. It's quite equipment intensive because you have two different parallel processes, and so it's quite CapEx intensive as well. And so this works really well if you have a lot of CO2, such as for a power plant on land, but it's difficult to take all of this equipment and put it on one ship because it will take up a lot of space and it'll cost potentially up to $30 million per ship, at least according to a study by the Oil and Gas Climate Institute. Additionally, it's actually the second regeneration phase, which is particularly energy intensive, and it results in gaseous CO2, which needs to be compressed, liquefied, stored in specialized tanks, and then moved by pipeline. And because ports are unfortunately not equipped with liquid CO2 pipelines yet, we thought that they might struggle to scale quickly with that type of a solution. So we took a different approach at Seabound, again using sort of first principles thinking. So we actually cut the whole carbon capture process in half, and then we use solids to capture CO2, so we don't need to do compression or liquefaction. So we do the capture phase on board, and then we do the regeneration phase on shore. That way we can reduce CapEx by building one regeneration facility for many, many vessels coming into a given location, and we can leverage economies of scale and land-based infrastructure for that second regeneration phase. Specifically, the way this works with the technology calcium looping that I mentioned is that we have quicklime, or calcium oxide, which reacts with CO2 to make limestone. And so we basically produce limestone on ships. And that's it. It's a very simple chemical reaction. It's a pretty simple device. We do have a patent pending for a compact version, but it's not rocket science by any stretch of imagination. And so we're continuously feeding quicklime pebbles, reacting in our device, ejecting the limestone pebbles, and temporarily storing that on board, whether it be in containers or perhaps a subsection of a bulk carrier hold. Then the regeneration phase is the opposite reaction on shore. We heat up the limestone, separate it into CO2 and quicklime. That way we can reuse the quicklime to capture more CO2 on another vessel, and then we sell the pure CO2, whether it be to make methanol or to sequester underground. Additionally, one last thing I'll say is that we can actually skip that regeneration phase because limestone is a product in itself, and it could be used for building materials, and this gives us a lot of logistical flexibility depending on where we are.
Now, while Seabound's technology uses quicklime, Valley Maritime uses a liquid called an amine to pass through the exhaust system. The process the company has involves saturating an amine tank with CO2 and then replacing the tank with a tank of unsaturated amine in port. And if you want to find out more about this technology, then look for that particular episode published in late February this year. The third CO2 capture system developer on the Blue Talk panel was Sigurd Jensen from Wärtsilä. Now, Wärtsilä has, as I said earlier, been developing a system for a while, and he appeared on the Aronax podcast 2 years ago to talk about the initial testing the company was investing in its facility in Moss, Norway. Well, 2 years later, and the company is ready to test the system on board a vessel. Of the three on the stage, Valley Maritime, Seabound and Wärtsilä, it's Wärtsilä with the aspirations for the much larger vessels.
Capturing CO2 is surprisingly easy. There are lots of different technologies to do that. The three of us here also show that we apply that technology slightly differently. We have a different perspective on sort of the energy usage. We think that if we can harness the waste heat that you have on a vessel, I mean, half of the energy content in the fuel goes out either with the cooling water or with the exhaust. Then that whole chain becomes very energy efficient, and we expect that we can get to 80% capture rate if need be. And then of course, then we need to liquefy it, but then we're only storing the CO2. We're not storing the solvent itself or the absorbent. But I think for shipping there are so many different applications. I think we will see a lot of different technology solutions as well. But for sure, I think we all prove that this works. The technology will work.
Sigurd Jensen from Wärtsilä on the abilities and capabilities of carbon capture. Now, the Wärtsilä trial is, as I said, going to be on a Solvang gas carrier. So, on the Blue Talk stage, I asked Tor Øyvind about the company's project.
The project we are talking about now, we're discussing 700 cubic CO2 tanks.
700?
Yeah, so which is a realistic amount of CO2 for a vessel of this size for a transatlantic crossing. If we should have a worldwide, maybe double or 2.5 times more tank capacity, but this is on a gas tanker which have 21,000 cubics of cargo capacity. So it's inside, it's smaller than ammonia, it's smaller than hydrogen, it's less than the other alternatives, and we go aiming for 80% or 75% capture on the main engine on this.
For one leg?
One leg, yeah. Yes. And shipping cannot do this alone. That's never going to happen. But there's about 200 projects with CCS in the world today, and there is storing place for 50 years, whatever, all that we have. So it is actually a quite realistic alternative which can help us in this phase. We have lack of green electricity to produce more advanced fuel or the alternative. So we really think this could be a good way.
Do you think you're going to be able to sell? I still find it quite an irony that we talk about decarbonising shipping and getting carbon out the air, and then we turn around in the same breath and say, and it's a product we can sell. Yeah. I find that really kind of a big irony. But do you think you can sell the CO2?
Yeah, we are working with that also. And when we try to describe the project, it's very difficult to say, is the CO2 a value or is it a cost? We have been a headache for solving this because it is also a product. And it depends how clean it is, and I also think if you go and put it in the ground, it will be important how clean it is, because it's with the value you're putting in it. So it could well be also a income, but we don't know. And I think for the two first vessel, or this vessel, the first one will always be 2, 3, 4 years ahead of because the system around also need to develop. But we hope and think that either you use a bunker barge, and we also with getting bunker and delivering CO2 at the same time, that we think will be very nice, or we go to terminal which handle gas anyhow. There could be a pipeline to discharge it also there. So the goal with this project is to really demonstrate the whole value chain from also the regulation. We are working with the Norwegian flag state to get it into a format we actually get the benefit from it. So it is, the target is to actually, what is the cost and what is how much can we capture, and is it possible to discharge? Where can we discharge? We have 700 ton here, so our customers are also very keen on to see how this will work, and therefore we think this is when we design it like this, it is transatlantic, and it is. So it is actually not a ferry, it's a long voyage, and the amount of CO2 is...
But if CO2 is considered a waste, if you sell it as a product, you're not going to be hindered by CO2 transboundary limitations as well.
That is one of the parts we need IMO, and the other one to sort out what is so you don't count it several places. So if my dream on a long term is you actually deliver it, and I get fuel back. I come with you with CO2 and I have electricity and I get the fuel back again. Then the circle is closed.
Circular.
But if you're making air fuel, and release the CO2, then it is out in the atmosphere again. So you don't need to be mechanisms, so count half of it or whatever. But that is thing which is sorted out now. And it is a question we need to be sorted.
And what's your relationship with the ports here? And Alicia, what relationship will you have to develop with ports? Because you're going to be having to load solids onto a ship. Mm-hmm. But you're doing it already. What kind of relationships do you need to have with the ports to be able to create that value chain that Tor was mentioning?
Well, to be honest, it's difficult because it's all new.
Yes.
The stuff you're unloading doesn't have a product code, for example. How does it work with import taxes? How does it work with VAT? All these stuff, by doing so, you learn. Yeah. The good thing is that the last talk was about partnership. We get a lot of support from ports, from authorities, to get the ball rolling, and but also from class authorities to get it done. And what we're doing is making a blueprint in Rotterdam, for starters, that we can duplicate in several other ports, so it's good fun, to be honest.
Are you having conversations likewise with ports about talking about, well, we're going to be bringing all of this into the port, but when we take it out, it's going to be a completely different product?
Yeah, so we're just starting to engage with ports now. I think one of the pieces of feedback that I've been excited about is that ports have relatively low amounts of CO2 that they can reduce within port, but they want to be a part of the solution. And that's because most of the emissions within the industry are out at sea. And so I think the feedback we've gotten so far is they like the decoupled approach that I think both of us have taken, because they can actually facilitate the higher volumes of CO2 reductions out at sea by enabling that. So that's one kind of positive anecdote. Additionally, so we're looking primarily at container vessels, but also at bulkers initially, because we move rocks around, and the bulk industry is more familiar with doing that and has the right portside infrastructure for doing that. So we're trying to find the path of least resistance, if you will, so that it's not a big challenge. And then also just to learn from our partners. So as you can probably tell, I'm not a shipping veteran by any stretch of imagination, and most of what I've learned about the industry has been through discussions and conversations with others who are experts. And so we're hoping that the ports can also guide us through this.
Because you're going to have the port costs that are incurred. There's the product costs of the amine solution or the solids. They're going to be costs. There's going to be the technology cost on board that's going to be considered by anybody who wants to do that. Going back to what Øystein's comment was about, from a ship owner perspective, looking at all of that, to looking at then at the sort of savings, the CO2 savings, carbon price, and the accountability of that. That's going to be a real, as you say, headache to sort of work all of that out, isn't it? So how do you envisage sort of a future there where you can engage more vessels with CO2 capture on board when you're bearing all of those costs?
I think you need to look at what is the alternatives, because that decides the cost. And when you're looking at reports now, you're talking about between $700 and $1,400 per ton of CO2. If you go into alternative fuel and calculate that back to fuel, you talk about $2,000 to $4,000 per ton of fuel. So you see, you have a huge margin here to with the CCS, if that is going to work. And to 20% increase in energy consumption, then you add 20% of a fossil fuel, which is $100 maybe, and you can add 100 more for storing and 100 more there, and you are still far below the alternatives.
So that was Tor Øyvind Ask from shipowner Solvang, a Norwegian shipowner keen to explore the potential of CCS as a tool to decarbonise shipping. He was on the Blue Talk stage in North Shipping in Oslo with me, along with Alicia Fredriksson, Seabound founder, Martin Lødevix, director, co-founder at Value Maritime, and Sigurd Jensen from Wärtsilä's onboard carbon capture team. Now, as you may have noticed, there are some regulatory issues that will need to be resolved with onboard carbon capture, not least how it fits into the energy calculations for shipping, and how the transboundary shipments of CO2 waste streams can be resolved. And it is the regulatory questions which we will likely be focusing on next with the Aranex podcast, as Gavin and I are in London for the IMO's next meeting of the Marine Environment Protection Committee. On the week before MEPC, it's also the next meeting, the 15th, of the Intersessional Working Group on the Reduction of GHG Emissions from Ships, where the aim is, amongst other things, to agree on a revised IMO strategy to decarbonise shipping. Now, unfortunately, the intersessional meetings are not open to the press, so we can't give you any direct updates from that meeting, but we can from MEPC the week after, when any decisions from the intersessional will be need to be formally agreed. So this is it for this episode of the Aranex podcast. Please remember to visit Fathom World to subscribe to the regular newsletter, where the stories you will hear on this podcast are delved into in much more detail. Also, remember to like and follow the podcast on whichever platform you do. It's easy to do and it won't cost you. And also, please share this podcast with colleagues and friends who have an interest in the transformation of the maritime and ocean space. My objectives of the podcast and at Fathom World is to report on the issues as openly and objectively as possible. I don't have a hidden agenda other than to make the use of the long time I've spent in the industry and the interest I have in reporting on the changes that are sweeping through it. Until the next time, my name is Craig Eason, and remember, you can get in touch with me either through LinkedIn or at fathom.world. Goodbye for now.